Hello, I am Ge and
I'm Ink.
today for our physics project we created a wind tunnel to visualize drag and how air moves along different surfaces.
So our objectives are to categorize air movement patterns and identify the types of surfaces that create vortexes, and to show how different surfaces are used to achieve different aerodynamic goals. We expect to identify the types of aerodynamic concepts through observing air movement on the surface of the object. We also expect that rounder and more streamlined objects to be more aerodynamic and have less drag force compared to other shapes. Smoother surfaces will have less drag force and better airflow.
So to build the wind tunnel, we first ordered the stuff. We had to build a water container that had tubes in it so that the water mist machine can make the water go up into this tube. And then we had to attach the fan on top of the box so that the air will push out. And then we created the wind tunnel using plywood, and then we made the straws at the ends to straighten out the wind. And then for the space where the smoke is coming out, we used a straw and then drilled holes in it.
When wind passes a square object, it creates vortex or swirling air patterns, particularly at the corner of the object. There's aerodynamic drag force acting on the object due to the resistance. The square shape creates turbulence and separate airflow, increasing drag.
This shape also creates vortex because the pyramid at the edge, at the trailing edge, it's a sharp end, so it creates vortex at the end.
When wind passes a circular object, it also creates a pattern of vortexes in the wake. The flow of air around a circular object tends to be smoother compared to a square object. The vortexes are generally more organized and symmetric. When wind moves past a cone object, it creates a pattern of vortexes in the wake. Similar to other shapes, the airflow around the cone tends to be more streamlined compared to certain other shapes. When wind moves past a pyramid-shaped object, it creates a wake with vortexes. The airflow around a pyramid can lead to the formation of vortices. The wake behind a pyramid may exhibit vortices in a pattern that reflect the shading of alternating vortex on either side of the pyramid, create a somewhat organized flow structure. When wind moves past such a hybrid object, it will likely exhibit a complex airflow pattern. The cone part may create vortices similar to a cone, and the spherical part may affect the flow in its own way.
This achieves our aerodynamic goals because at first, without the sphere, the cone will have edge that will create vortexes, but the sphere will make it so that the air moves around the back smoothly. And the cone in the front already goes through the air easily except for the back. For our discussion, we faced many engineering problems such as water leaks and creating the smoke itself for the wind tunnel. Because well, first the water started leaking, so it was a hassle. We had to clean up and everything, and then also the hose was kind of small, so the smoke wasn't coming out.
However, we managed to collect enough data to put in the formula to find the drag coefficient.